All right, today we're jumping right in to unlock the code behind a really fascinating system of numerical patterns and transformations. We're going to see how some pretty simple everyday math can actually create some seriously complex results. So yeah, let's get into it.
So we're kicking things off with a puzzle. It's this cryptic little sequence from our source material that, at first glance looks complicated, maybe even a bit random. But trust me, there's a very clear logic hiding in there.
And here it is. This is the sequence the source gives us. It seems to be using the number 96 as a starting point. And right away, things look a little weird, right? I mean, we see normal math, like 2 times 48 equals 96. Okay, makes sense. But then it says 6 times 8 equals 68. Wait, what? We all know 6 times 8 is 48. So what is going on here? This is the central mystery we're going to unpack, where normal math seems to be playing by a whole new set of rules.
So that's the big question for today. What does this actually mean? And how can you possibly get a pattern this intricate from just basic arithmetic? Well, the answer is all about understanding the tools that are being used, and one of them works in a way that might be a little different from what you're used to.
To solve this thing, we first need to get really clear on two fundamental operations that are in play here. They might seem kind of similar, but as you're about to see, they operate in two completely different worlds. First up, good old addition. You know this one, I know this one, we all know this one. It's simply about combining the values of numbers to get a total sum. It's simple, it's straightforward, it's the backbone of math. And then there's our second tool, concatenation. Now this is a different beast altogether. With this, we're not combining values at all. We're just joining the digits themselves, like linking cars on a train, just sticking them end to end to make a new, longer number.
And this slide just makes the difference so obvious. With addition, 12 plus 34 gives you the value 46. Simple. But with concatenation, if you concatenate 12 and 34, you get the number 1,234. See? You start with the same two numbers, but you end up in completely different places.
So, okay, we've got these two very separate ideas, adding values and joining digits. On the surface, they seem to have absolutely nothing in common. But the real aha moment, the key insight that comes from our source material, is finding this hidden bridge that actually connects the two.
And that's really the question, isn't it? I mean, are these two operations related at all? One feels like pure math. The other feels more like something you do with words or text. Is there any real mathematical connection between them?
And believe it or not, the answer is a huge yes. The source material gives us this crucial piece of the puzzle. Concatenation isn't just some weird text trick. You can actually describe it with a precise mathematical formula, using the operations we already know and love. This right here, this is the key that unlocks the whole thing. And here it is, the formula that builds that bridge. To concatenate two numbers, let's call them a and b, you just take a, multiply it by 10 to the power of n. And don't worry, n is just how many digits are in b, and then you just add b to the result. It's a really clever way to turn that visual act of just sticking digits together into pure, clean arithmetic. Let's just walk through that real quick with our example, 12 and 34. So our b is 34, which has two digits, so n is 2. Easy enough. So we take our a, which is 12, and multiply it by 10 to the power of 2, which is just 100. That gives us 1,200. And for the final step, we just add b, which is 34. And what do you get? 1,200 plus 34 is 1,234. We just did concatenation using only multiplication and addition. Pretty cool, right? Okay, so now we have our tools. We understand addition, we understand concatenation, and we know how they're connected. We can finally go back to that original puzzle and see how this whole system actually works. We're ready to decode this thing. So there's just one last piece we need to solve this. The sequence uses another really simple operation, just summing the digits of a number over and over again until you get down to a single digit. You might have heard this called finding the digital root of a number. So let's look at the source again. The sequence starts with 96. If we sum its digits, 9 plus 6, we get 15. That's still two digits, so we do it again. 1 plus 5 equals 6. So now, let's put it all together. That confusing sequence from the start, it wasn't one long equation. It was a demonstration of a system with different rules. It was showing us that 48 can be factored into 6 and 8, and that those factors could then be concatenated into 68. And it was also showing a totally separate operation, that the starting number, 96, can be reduced to its digital root, which is 6. We've cracked it. So now that we understand all the individual moves in this system, concatenation, addition, summing digits, we can zoom out and look at the bigger picture.
What's the point of all this? According to the source material, what is a system like this actually for? The source calls this whole thing a unified theoretical framework for numerical transformations. I know, that's a mouthful. But it's really just a fancy way of saying it's a consistent system, a set of rules, for changing numbers into other numbers or symbols in a way that's totally predictable.
So here's the core idea. The framework starts with really, really simple building blocks. You've got addition, you've got concatenation, you've got summing digits. But by combining these basic tools in specific sequences, you can build these incredibly complex systems. And the goal? Well, the goal is to create powerful frameworks for analysis, maybe for building codes, or for finding really subtle hidden relationships in huge amounts of data, or even looking for patterns in texts.
And that leaves us with one final, really interesting question to think about. When we use systems like this on numbers or texts, are we actually discovering some deep, hidden structure that was there all along? Or are we just creating our own patterns, using the rules that we ourselves designed? It's a question that really gets to the heart of what math and code and meaning itself are all about.